Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 106. Construct binary tree from in-order and post-order traversal. In this video, we're going to practice or review a solution based on recursion. First, let's look at the problem statement. So given two integer arrays, in-order and post-order, where in-order is the in-order traversal of a binary tree, and post-order is the corresponding post-order traversal of the same tree. So we are required to construct and return the binary tree. So here are two examples. So example 2 is very special because here it contains only one node, right? So this can be regarded as a special case or as special case, I would say. And the first example, so from the post order, we know the root value is 3, right? And then from this 3, here is also 3. Then to the left of 3, so this will correspond to the left subtree, and this part will correspond to the right subtree. So before we do look at the analysis, let me point out here. So here, in-order and post-order consist of unique values. So this assumption actually is very important because when we do the coding, so we want to find this index corresponding to the root value 3 here. And then if the value is not unique, so there will be confusion. So with that said, actually we're going to directly look at the analysis. There are some other constraints we'd better to review that in practice. So here in this video, we're going to review the treatment based on recursion. And in this video, we want to point out that it's important to pay attention to the index. And as we mentioned in this problem, the value uniqueness assumption is very important. So here, one thing we want to notice is that because the in-order and post-order are the traversals for the same tree, but with different orders, so the length of them should be always the same. So therefore, let's write our base case for the recursion. So if not in order, it means that the tree is a null tree. So we're going to return null, or you can just write return or write this. And then if the in-order or post-order is not null, then we know the last element in the post order is the root value. So let's first get that value. So post order, we can use pop. This operation is legal or valid. The reason is that we have done this if check, and in order, post order have the same length, and this is not null. So once we get this value, so we can construct the root. So root is a tree node, right? So we can pass the value to be the v. But we need to set the left subtree and the right subtree. So in order to determine the left subtree, we need to find the index of this root value. You can think of this v as 3 here, right? So here the index is 1. So let me find this index. Let's call it idx. So it's in order. So this is a list. I'm going to call it index for this value. And then this will give us 1 if we use example 1 as a demonstration, right? And then we are ready to look at the left subtree and the right subtree. So we are going to do the setup and construction in same line. So let's call this build tree. And then for this self-call, the in-order traversal, in-order list or in-order traversal of the left subtree will be corresponding to up to this index, right? So this is the none here. And then let's find the corresponding post-order traversal. We know that the in-order traversal and the post-order traversal should have the same length. Therefore, we write idx here. So this is for the left subtree, which is very routine. For the right subtree, we need to pay attention. So self build tree. So here, if we do the in order, so we cannot include this guy in the in order. We cannot include the root. Notice that the root has an index that is idx. So we are going to use in order. So we are going to start from idx plus 1, then forwards. However, for the post order, because we have already popped this one, then it should be start from here. That is starting from index. So we are going to write idx. So notice that in the first call, self call, so here is up to index for the same length. And here we need to make sure this is idx plus 1, and here is idx. Here we write idx plus 1. You can imagine that because we have popped one element in the post order, right? So now if we write idx here, so the length will be different, right? So if we write idx plus 1, it corresponding to ignore this key value, this 3 here. So therefore their lengths are the same. So with that done, so we actually can return the root. So this piece of code actually forms a solution format to this problem. So before we make any comments, let's first do a check. Yeah, it passes the first example, I guess. So now let's look at generic case. Yeah, it passes all the generic cases. So I guess, yeah, that's about it for this specific problem. Here we are doing this problem using recursion. The reason we think of recursion for this problem is due to the fact that we can regard the tree abstract data type as a recursive data type because they can be defined recursively. So with that said, I guess that's about it for this video. Thank you.